Hi dear students, this is the fifth part of fourth module of EST 100 Engineering Mechanics. In this presentation we will see inclined projection on a level ground. Inclined projection on a level ground means the starting point and ending point of the projectile will be on the same horizontal level, as you can see from the figure. Now the projectile is projected with an initial velocity u at a particular angle alpha, as you can see from the figure. Now the velocity component can be split into two, along horizontal as well as the vertical. As along horizontal direction the velocity component is ux equal to cos alpha, along the vertical component the velocity component is u sin alpha, and this is the trajectory of the velocity u. This is the line of action of the velocity u, and it is making an angle alpha with the horizontal. You can see the projectile initially traveling along a curved path reaches to a maximum height point here. This is the maximum height point and this distance is the maximum height, and after that it travels along this curved path and reaches the final destination point B. So along the motion the horizontal component of velocity always remains constant. There won't be any change in the horizontal velocity component, therefore the acceleration along the horizontal direction is always taken as 0, but the velocity along the vertical direction changes. Initially the velocity component along the vertical direction is u sin alpha, but once it reaches to the maximum height point the velocity becomes 0, and again it has some velocity, and finally once hitting the ground it will have again some velocity. So let ux equal to component of velocity along x-axis and ax acceleration along the x-axis, that's equal to 0. Uy component of velocity along the y-axis, actually it is y-axis, and ay acceleration along the y-axis. As we know, the acceleration along the y-axis or the vertical direction is acceleration due to gravity. If it is against the gravity then minus g, if it is towards the gravity then it is plus g. Now let u is the velocity of projection, alpha angular projection. Now we are splitting the entire motion into two, that is vertical motion and the horizontal motion. For vertical motion, initial velocity is along the vertical direction is u sin alpha upward, acceleration is g, negative for upward motion and positive for downward motion. At maximum height point vertical velocity component is 0, this is very important, and for horizontal motion velocity component is always u cos alpha and remains constant, therefore acceleration will be 0. Now we are going to derive an equation for the trajectory of the projectile. That means equation which satisfies at each and every point of this path, that is what is known as equation for trajectory. For that we are considering a particular point P somewhere here, that is this point P is the projectile at time t. So initially at time 0 it was at the initial position or the origin. Now at time t it has reached a point P. Its coordinate be x and y. That means this vertical distance is y. From the ground level to this point P the vertical distance is y. From y axis to this point P the horizontal distance is x. That is what is meant by the coordinate P x y. Okay. Now we are considering a point P on the trajectory. Let pxy represent the position of the particle after t seconds. Now considering the vertical motion, we have the general equation s is equal to ut plus half a t square. By time t the particle has traversed a vertical distance of y, therefore s can be replaced by y, therefore y equal to, here it is ut, u initial velocity along the vertical direction as I have already told is u sin alpha into t. So this term is actually ut plus half a t square. Half is the t square is the here, as we know, since the projectile is moving against the gravity, therefore acceleration is minus g. So we will get y is equal to u sin alpha t minus gt square by 2. This is equation 1. Keep it there. Now consider the horizontal motion. The horizontal distance covered by the particle with time t is actually x, since the coordinate of p is x. Therefore the horizontal distance is x. X is equal to, here also we are using the same equation, s is equal to ut plus half a t square, but along the horizontal direction acceleration is 0, therefore the second term vanishes. Therefore instead of s we are writing x. X is equal to u cos alpha, that is the horizontal velocity component into time t. So from this equation you will get t is equal to x by cos alpha. Now you can substitute for t in this equation. So this equation becomes y is equal to u sin alpha into, instead of t we are writing x by u cos alpha minus half into g, instead of t we are writing x by u cos alpha all square. So if you reduce this equation you will get y is equal to, here you can see sin alpha cos alpha is sin alpha divided by cos alpha is there, that will become tan alpha, and this u and this u will cancel, therefore x tan alpha minus half into g is there, this u square we are taking outside, so minus 1 by 2 u square into g x square divided by cos square alpha. This is the general equation for the trajectory of a projectile. So this either you can directly use this equation, or this equation can be further simplified as we know 1 by cos square alpha is equal to c square alpha, that's equal to 1 plus tan square alpha. Therefore instead of 1 by this cos square alpha, we will substitute 1 plus tan square alpha. Therefore equation becomes y is equal to x tan alpha minus half into gx square gx square by u square into 1 plus tan square alpha. So either of these two equation can be used as an equation of trajectory. So some questions will be there to directly derive this equation, or this equation is usually used for solving the problem. So please by heart this equation, this very important equation. Now we want to find an expression for the maximum height. Maximum height is nothing but this distance. This is the this distance is the maximum height, maximum vertical distance. So we want an expression for the maximum height. So maximum height is when the particle reaches maximum height, the vertical velocity component will be 0. That condition we are utilizing here. That is if you consider the vertical motion of the projectile, initial velocity is u sin alpha and final velocity is 0. Now acceleration is minus g since the motion is against gravity. We have v square minus u square equal to 2x. That is a fundamental equation. In that you are substituting v is equal to 0. Instead of u, initial velocity along the vertical direction is u sin alpha. Therefore u square becomes u square sin square alpha. On the right side it is 2as, 2 is there, acceleration is minus g, therefore minus 2g into, actually s is nothing but the maximum height travelled. Instead of s we are writing h max. From that you will get the expression for h max equal to u square sin square alpha divided by 2g. Okay, that is the expression for the maximum height. Now next one is time to reach the maximum height and time of flight. Time to reach the maximum height, you can consider the vertical motion of the projectile from the initial starting point to the maximum height point. That vertical motion you analyze. Consider the vertical motion from the initial position to maximum height. We have the general equation v is equal to u plus at. Here v is equal to 0 and u is equal to u sin alpha and a is equal to minus g. Therefore substituting you will get 0 equal to u sin alpha minus gt. From that you will get the time to reach the maximum height, t is equal to u sin alpha by g. This equation you can by heart it, and from this equation you can directly calculate the time to reach the maximum height. If the question is there to calculate the maximum height, you can directly substitute in this equation. There is no need to do any derivation. Now consider next one is time of flight. We want an expression for the time of flight. Time of flight means the total time taken by the projectile from the starting point to the ending point. That is what is meant by the time of flight. That is from the entire time taken by the projectile. So now considering the entire distance, the general equation for the trajectory was s is equal to ut plus half at square. We are considering the vertical motion. Now let px y be a particular point in the projectile. Now y is the vertical distance travelled by the projectile in time t. Therefore y is equal to ut, vertical component of velocity u sin alpha, into t minus half gt square by 2, since acceleration is minus g. So this is the fundamental equation or general equation. Anywhere we can substitute. Now we are substituting. If we want to find the time of flight, at the end of the flight, the particle will be striking the ground back at point B. I can show you. At the end of the flight, the projectile is striking at this point B. So at point B, the vertical distance is 0. Y is equal to 0 at point B. At that time, the time t is the time of flight, capital T. So as a boundary condition, what we will do is, now consider time, and at the end of the flight, that is time t equal to capital T, y is equal to 0. These two conditions I am substituting here. So instead of y I am substituting 0. Therefore 0 equal to u sin alpha into, instead of this t I am substituting time of flight capital T into t minus g t square by 2. From this equation you will get t is equal to 2u sin alpha by g. That is the fundamental equation to calculate the time of flight. Using this equation we can directly calculate the time of flight. Now next one is horizontal range and maximum range. Horizontal range means the horizontal distance travelled by the projectile during the entire motion. So this is the horizontal range. This one is the horizontal, from here to here. This is the horizontal range. So the time taken by the projectile from initial point to final point is time of flight, capital T. So how you will get the horizontal range is, horizontal range you will get, since it is the distance along the horizontal direction, if you multiply the horizontal velocity into time of flight, then you will get the horizontal range. Why there is no second term is acceleration is 0 along the horizontal direction. Therefore, since the velocity along the horizontal direction is constant, constant velocity multiplied by time will give the distance. Therefore, horizontal range is equal to horizontal velocity in time of flight. As we know, horizontal velocity component is u cos alpha into horizontal range, time of flight it was 2u sin alpha by g. So multiplying you will get u square into 2 sin alpha cos alpha by g. So 2 sin alpha cos alpha is sin 2 alpha, therefore u square sin 2 alpha by g. This is the equation to calculate the horizontal range. So from this equation, if you clearly look or closely look upon this equation, what you will conclude is its value, horizontal range value is depending on sin 2 alpha. U and g is constant, therefore it is depending only on the value of sin 2 alpha. So once the sin 2 alpha value is maximum, then the range will be maximum. Range will be maximum when sin 2 alpha. The sin 2 alpha maximum value of sin 2 alpha is 1. Therefore, when sin 2 alpha equal to 1, the range will have the maximum value. This implies that alpha equal to 45 degrees. So it's sin 2 alpha. Sin 90 is 1. So 2 alpha equal to 90, that means alpha equal to 45. So alpha equal to, for an angle of alpha equal to 45 degree, we will have the maximum range. So if you want to cover maximum distance by throwing at a particular by throwing a projectile, you have to throw the projectile at an angle of 45 degree, then only it will reach the maximum height. This is applicable in the case of javelin throw, shot put, everything. So if you throw the javelin at an angle of 45 degree, then only you will get the maximum, you can cover the maximum distance. This is the application of this one. Alpha equal to 45 degree, you will get the maximum range, and the maximum range is given by sin 2 alpha value is given as 1, therefore u square by g. So r max equal to u square by g, and since r is equal to u square sin 2 alpha by g, therefore each value of sin 2 alpha there will be an r value. But sin 2 alpha equals sin 180 minus 2 alpha. These two are same. Sin 2 alpha equals sin 180 minus 2 alpha. Therefore 2 alpha equal to 180 minus 2 alpha. Therefore alpha equal to 90 minus alpha. Means for both angle of projection with alpha equal to alpha and 90 minus alpha, with the same velocity of projection, we will have the equal range. I want to tell only this thing, that is for the two different angles we will have the same range. That's all.